Bismillahirrahmanirrahim. In today's lab, I am going to explain about lab number 10. Basically, the title of lab number 10 is to display and manipulate the output of data transfer instruction using emulator 8086 software tool. Basically, there are two data transfer instruction. One is move and second one is exchange. The objectives of today's lab is to display and manipulate the output of move instruction using emulator 8086 software tool, and the second objective is to display and manipulate the output of exchange instruction using 8086 software tool. Basically, these two instructions are also called as data transfer instruction, and here in this lab I am going to explain about the move and exchange instruction one by one. First of all, I'll explain the syntax of move instruction, then I'll explain all the details of move instruction. First of all, move is basically the short form of basically MOV instruction is the short form of move word. Move word is basically used to transfer the location, transfer from one to another. So basically that move instruction will have two operand. One is the source and second one is the destination. So the syntax of the move instruction is move MOV space your destination operand, then comma source operand. So the move instruction move the data from the source to the destination while remaining the source unchanged. For example, if I take an example, move AX comma DX, as written here, you can see that move AX comma DX will move the data from the source register, that is DX, to the destination register, that is AX, and the data of source register remain unchanged. Similarly, you can say the move command is also used as move AL comma CH. In this, the data of CH will be moved to AL register. But in command number 3, you can see that move BL comma CX. Here you can see that the destination register has lower size as compared to the source register. So this type of move instruction is not allowed, because as the destination has lower capacity to store the data, whereas the source has higher capacity. So this type of movement is not allowed. You cannot move the data from any 16-bit register to 8-bit register. Next command is move AH comma 56. This will this statement will move the data 56 to AH register, but actually the here 56 is not representing any decimal, hexadecimal, or binary or octal interpretation. So that compiler will assume that 56 as a decimal value, and the hexadecimal converted value of 56 can be seen in AH register. The next command is move BX comma 0 ABCDH. By simulating this command, you can see that the value 0 ABCDH will be moved to BX register. Basically, this ABCD is a 16-bit value, and you also know that BX register will have two parts. One is BL part and second one is BH. BX register has two basic portion, lower and higher part. So you can see CD value in the lower part and AV value in the higher part. Next is move 678 comma BL. This is not allowed because you can see that here 67H, which is the destination location, is a constant value, and you cannot move any value in a constant value. So this is not allowed. This give you an error, and this movement is not allowed. Next is move DS comma 34678. Again, this is not allowed. You cannot move data, you cannot move any constant value directly to any segment register. I'm not talking about just the data segment register. You cannot move a constant value to any segment register. So move SS comma any constant value is not allowed. Move CS comma any constant value is not allowed. Move DS comma any constant value is not allowed. So basically this statement is not allowed. If you want to move a value to move or assign a value to DS register, you need to use any intermediate general purpose register for that purpose. Next is move DS comma BX. This is the allowed that in that case the value of DS will be updated by the value of BX, whereas BX remain unchanged. Then next is move bracket start 2 3 4 5 8 bracket and comma AH. This will basically in that statement the brackets represent that this is an offset address, so the value of AH will be moved to that offset. And if I talk about the physical address, so this offset will combine with the base address as per the formula of physical address, which is base address multiplied by 10H plus offset address. So actually the value of AH will move to the physical address, which you can find by using that formula which I have already mentioned. I repeat the formula. The formula is physical address is equal to base address multiplied by 10H plus offset address. So basically the value of AH will be moved to that memory location whose offset is representing here. Next, move DI comma 568. This will again, here you can see that you can see a square bracket against the DI, so that DI will also be treated, the value of DI will also be treated as an offset address. So 56 value will move to that offset address, that physical location which can be generated using that offset address. That 56 will be moved to that memory location. Next is move DI comma SI, and you can see the square brackets against the DI and SI. So these two are again representing memory locations. So move command is not allowed to directly move data from one memory location to another. You need to use an intermediate register for that purpose. Directly memory to memory movement is not allowed. So this again, this movement is not allowed. This command will generate an error.